Okay, for section lesson 2.1, multiplying integers, I want to first point out that we're dealing with standard 7th grade number sense, standard 2, where we're dealing with multiplication and division and of fractions to multiply and divide rational numbers, positive and negative numbers, okay? So yes, we're going to see fractions, but the focus is on multiplying and dividing rational numbers, including positives and negatives, all right? So real quick, the start of chapter 2 has 3 lessons: multiplying integers, dividing integers, and then applying operations. So these are the first 2 lessons that you're really going to want to focus on. Notice the standards are all the same: 7.NS.2, 7.NS.2a, which is still just NS2. NS2, NS2b, NS3 is word problems involving adding, subtracting, multiplying, and dividing. But obviously, they're just going to be focusing on multiplying and dividing, okay? So, coming back here, what we're going to be working on is multiplying integers using a number line, all right? So what we want to understand when we read this section, you can use a number line to see what happens, to prove what happens when you multiply a positive and negative number. So in this case, what we're trying to do in this first example is we're trying to multiply 3 times negative 2. Okay? Instead of writing 3 times negative 2, we just write 3 next to the parentheses negative 2. That means multiplication. So we're going to get used to that in middle school. Another way we might see it is 3 dot negative 2. That's another way of showing multiplication. But here, we're just going to do 3 parentheses negative 2 and parentheses. So to graph negative 2, you would start at 0 and move 2 units to the left. All right, that's where negative 2 is on the number line. So this isn't too confusing. This is just, they're trying to get you to think. So be ready to think. All right, so 3 negative 2's means negative 2 plus negative 2 plus negative 2, because multiplication is a shortcut for repeated addition. This is 2nd grade, this is 3rd grade. Just now with 7th grade, it's just with negatives. All right? Repeated addition is 2nd grade standard, and then in 3rd grade we introduce 2 times 3, right? 2 3 times. So to graph this, we're going to start at 0, and we're going to move 2 units to the left. How many times? 3 times. No problem. 1, 2, 3, 4, 5, 6. So the result is negative 6. The change in Henry's balance was negative 6. Cool? Lisa plays a video game. Oh, the next example. The next example has us trying to figure out what 2 times negative 3 is. In this case, we have negative 3 2 times. So negative 3 and negative 3. If we show this on a number line, we're going to go 1, 2, 3, 1, 2, 3. So we go from negative 3 to negative 6. We're counting negatives. We're counting 3's in the negatives. Okay? So we end up with a score of negative 6. There's something very specific that I need to explain before I go into modeling with integers and going through all of these different kinds of rules. All right? So what I want to make sure that everyone here understands is when you're multiplying positives and negatives, a positive times a positive is always going to be positive. All right? A negative times a negative is always going to be a positive. A positive times a negative will be negative. And a negative times a positive will also be a negative. And one way I like to remember this, and I've heard this from a few other teachers, is when the signs are the same, they're friends, and they're happy together. They're positive. When the signs are the same, they're friends. They're positive. But when the signs are not the same, it's harder for them to be friends, and things can get negative. All right, so that's just a cute way of remembering. Please don't apply that to your own life. This is only in this made up world of fictional integer signs. Okay. All right. Now, okay. So when we're modeling integer multiplication and we're using counters to represent positive and negative numbers, all right, positives yellow, negatives red. All right. This example is having us find the product multiplication of -3 and -4. So what's 3 times 4? 12, yeah? And a negative times a negative is going to be what? Positive. So just from that rule, we can say that -3, -4 is going to be positive 12. So that's not too confusing. But what we want to be able to do is explain in the real world, in the real physical world, how this makes sense. Like, why is it 12? Well, here, they're asking us to write -3 times -4 as -3 groups of -4. And -3 groups can't exist. So what we're going to do is, we're going to write it this way knowing that that's the opposite of having 3 groups of -4. Just like on a number line, all right, 1, 2, 3, positive 3 is the opposite side of -3. Okay, this is they're opposites on the other sides of the 0. Cool? So what we want to do is we want to pay attention to the fact that using negative counters to model 3 groups of -4, even though we know it's going to equal -12, that isn't the problem we're trying to solve. We're trying to find the product of -3 and -4. So if we know that 3 groups of -4 is going to equal 12 negatives, right? Then what is the opposite of that? What is -3 groups of -4? Just flip them over. The opposite of negative is positive. So just flip those over, and what do you get? You get -3 groups of -4, which equals 12 positives. All right? Okay. Now, if this idea of how -3 groups of -4 is the opposite of +3 groups of -4, if this being the opposite of that is too much, or is confusing, or doesn't make sense to you personally, then that's okay. This isn't the model that you're going to use to explain. All right? So we're just going to move on, and we're going to look at this other example of understanding multiplying integers, where the product of 2 integers with opposite signs, notice we're talking about integers with opposite signs, is going to be negative. And we've already talked about that. If the signs are different, they're not going to get along, and it's not going to be positive. It's going to turn a little negative. So the product of 2 integers with the same sign is positive, right? If the signs are the same, it's going to be positive. And the product of 0 and any other integer is going to be 0. So 0 times anything is always 0. So that's all this is trying to say, is the multiplication property of 0 makes anything times 0 equal to 0. That's all this is trying to say. These are properties of operations. All right? There's the multiplication property of 0 and the distributive property. These are properties that you can use to explain. Now, if you like using properties, definitely refer to them. But if you don't have an interest in learning this language for understanding multiplication and integers, then just go ahead and skip it, all right? Now, the examples here, 13 times -3. If we know that a positive times a negative is a negative, positive times a negative is a negative, then we know that the answer to 13 times negative 3 is going to be a negative number, right? It's going to equal a negative number. And 13 times 3, I'm just going to tell you that it's 39. But if we were to actually figure this out, 13 times 3, 3 times 3 is 9, 3 times 1 is 3, and we're good, then the answer is going to be negative 39. So I don't want this to get too complicated, all right? If you know the multiplication rules and you know how to multiply, then you're going to be able to do this standard just fine, all right? The second example, negative times a negative. If the signs are the same, they're going to get along and have a positive time. So a negative times a negative is going to be a positive. And 5 times 8 is 40. So we're going to end up with positive 40. All right? So I don't want to make this too complicated. And these examples really are just making sure you know the multiplication rules for signs. How to multiply different signs and the same signs. So that's what we're practicing here. And that's it for multiplying integers. I'm going to move on to dividing.